Good evening, ladies and gentlemen, boys and girls, friends and neighbors, or good morning, whatever the case may be. Today we are going to do a brief review over Unit 10, Lesson 2. This is a very important topic, certainly worth a review. And we notice here are the four trig identities from Unit 10, Lesson 2. These are called the sum and difference identities for the sine and cosine. We know sine of A plus B is sine of A cosine B plus sine of B cosine A. Sine of A minus B is sine of A times cosine B minus. So if I'm subtracting two angles, it's going to be the difference of sine of A cosine B, sine of B cosine A. Okay. If I'm adding two angles, sine of A plus B, it's going to be the product of the sine of A cosine B plus sine of B cosine of A. And then if we can recall about the cosine of A plus B, cosine of the sum of angles is going to be cosine of A cosine B minus sine of A sine of B. And the cosine of A minus B is equal to the cosine of A cosine B plus sine of A sine of B. These are important identities. These are four important identities that we use to prove many other identities. That's why these are so important. Not so much that we're going to use them to find the exact value of a sine and cosine, but so that we can prove other identities. That's why they're so important. So what we're going to do today is we're just going to do some examples that will be on the written assignment and on the Google form for later on this week. And you will want to take notes for this assignment and post them. You're just going to have to find a blank page in your interactive notebook or put them in a notebook paper and take a pic and post them in the particular Google assignment for Unit 10, Lesson 2, Review 2. Okay, so let's go on to the very first example using the sum and difference formulas for sine and cosine. So example number 1, let's say for a moment that I want to find the exact value, and this is key here. I want to find the exact value of the cosine of 7/12 pi. And again, like we did in last week's video, 7/12 pi is not an angle. That is not one of the nice angles on the unit circle. But we did discover last week that it's probably going to be square root of 6 minus square root of 2 over 4, or square root of 2 minus square root of 6 over 4, or square root of 6 plus 2. But we don't matter. That doesn't matter. What we're going to do is we're going to evaluate this, because this is going to be similar to what you're going to find on the Google form. Different ways to find the exact value of a cosine of 7/12 pi. The first thing I want to realize is that 7/12 pi is the same as 9/12 pi minus 2/12 pi. This is a true fact. Okay, and you may not have to pause the video because I have these problems already worked out. So there's going to be time that you might have to pause the video just to catch up with your notes. Okay, so I want the exact value of cosine of 7/12 pi. I know that 7/12 pi is 9/12 pi minus 2/12 pi. These are both on a unit circle, but today all we're going to do is get to the point. We're going to go to a problem similar to what's on the Google form. Here we go. So if the sine of 7/12 pi is equal to this, then the cosine of 7/12 pi is certainly equal to cosine of 9/12 pi minus 2/12 pi. And this, I'm going to use a formula for that. Which formula am I going to use? Well, I'm going to use the subtraction. I'm going to use this formula right here. I think I have it written. Nope. I'm going to use the formula for this guy right here. The cosine of A minus B. And I recall that that's going to be cosine of A, and we can always go back to your notes. No one's ever going to ask you to memorize these formulas. You will always have the formulas at hand that you can use. You don't need to memorize them. You just need to know how to use them. So here I have, this is the one I'm going to use right now. So if I'm subtracting two angles, it's going to be the addition of cosine of A, cosine of B, plus sine of A, sine of B. And so this is going to be, true or false, this is going to be the cosine of 9/12 pi times cosine of 2/12 pi plus the sine of 9/12 pi times the sine of 2/12 pi. And keep in mind, ladies and gentlemen, if I wanted to, and at this point right here, I'm going to stop because that's what the Google form is going to be similar to, the questions on the Google form. I could actually, I know this is 3/4 pi, cosine of 3/4 pi. This is cosine of 1/6. And I could go one step further, but I don't need to right now. We did that last week. We don't need to. And I could certainly find those values. But right now, I know because of this identity for cosine of A minus B that this thing is equal to this. These two things here, underlined in blue, are equal. Well, you know what, ladies and gentlemen, boys and girls? There's another way that I could evaluate exactly the cosine of 7/12 pi. What would it be? Well, true or false? Is 7/12 pi 3/12 pi plus 4/12 pi? You better believe it. So guess what I could use? If that's the case, then couldn't I use, then isn't the cosine of 7/12 pi equal to the cosine of 3/12 plus 4/12? Yes, indeed it is. And so now guess what I can use? I can use the formula for the cosine of A plus B. And the cosine of A plus B is going to be the cosine of A, cosine of B. And if it's plus, I don't remember it. I don't remember. I'm going to go back right there. Let's see, go back, and right there it is. If I add the angles, it's going to be the product of cosines subtracted. I'm going to subtract from it the product of the sines of the angles. Okay, so therefore this, yeah, I think I still have still have the blind on it. Yep. So what's that going to be? It's going to be the cosine of 3/12 pi times the cosine of 4/12 pi minus, sine of 3/12 times the sine of 4/12. And this, ladies and gentlemen, this statement is equal to this statement. Okay? There's going to be several problems like that on the Google form. So you're going to need to know those formulas. You're going to need to apply those formulas well to be able to do that Google form. And keep in mind, you are encouraged. I'm excited about FaceTiming, that you all are FaceTiming together to do that Google form. So there's no problem with you doing that at all. So let's see if we can find another value for cosine of 7/12 pi. Well, before I get there, is this statement true or false? If I have the cosine of pi over 2 minus a, well, here I am subtracting two angles. That's going to be the cosine of pi over 2, times the cosine of a, plus sine of pi over 2, sine of a. What's the cosine of pi over 2? The cosine of pi over 2, ladies and gentlemen, is 0. So this is a big giant, this guy right here is a big giant 0. The sine of pi over 2 is 1. So therefore, the cosine of pi over 2 minus a is the sine of a. And that gives us another identity. This is another identity right here, the cosine of pi over 2. And we knew that anyway. I mean, we knew this from the geometric definitions of the trigonometric ratios. And we can show that now. We can verify that with the sum and difference formula. So that's kind of neat. Okay, so how are we going to apply that? Well, in like manner, so hey, what's the sine of pi over 2 minus a? Well, if I'm going to do the difference of an angle, a minus b here, if I have the difference of two angles, that's going to be the sine of pi over 2, cosine of a, minus cosine of pi over 2, sine of a, looking at the formula from the first page there, the sine of a minus b. And guess what this is? Sine of pi over 2 is 1. So that's going to be cosine of a. And this guy right here again becomes a great big giant 0. And 0 times sine of a is 0. So guess what? Here's another identity, ladies and gentlemen. The sine of pi over 2 minus a is equal to the cosine of a. That's very interesting. That's, whoopsie, I'm going to go back up here. I don't know what happened here. Come down here. Come here. Let's see, where are you? All the way down. You're probably all the way down at the bottom of this sheet right here. I am. And yeah, so now tell me, I can use this identity to come up with another value for cosine of 7/12 pi. What is the cosine of 7/12 pi? This time this is my A. Another identity, another equal, something else that equals cosine of 7/12 pi is the sine of pi over 2 minus 7/12 pi. I would look for this also on your Google form. Okay? All right, so let's do another problem. The last example, and this is a toughie example. Let's go here and let's turn on the blind. And now I want the exact value of this guy right here. And this is going to take some geometric definitions, the trigonometric ratios. So give the exact value of the sine of inverse tangent of 3/2 plus inverse cosine of 1/4. Okay, this is a 2 here. Let's not forget that. And what do you know? The first thing you know is that this is an angle. Inverse tangent is an angle, and you had an example exactly like this on last week's video. This is just another example to help you. You know that this is an angle. Tangent of A is an angle. And we know that the inverse cosine of 1/4 is also an angle. So guess what this is? This is actually just the sine of A plus B. And so now we're back to the sum formula for sine. And what is the sine of A plus B? By the formula, it's sine of A cosine of B plus sine of B cosine of A. So what I need to do is I need to take these two statements right here, ladies and gentlemen, and from those two statements, figure out what the sine of A, cosine of B, sine of B, and cosine of A are. And how are we going to do that? Well, we're going to come up with some right triangles. The first thing we're going to do is if we know that A is inverse tangent of 3/2 and that A is an angle, what do you know? Well, what do you know? You know that the tangent of A is 3/2. And what am I going to do? I'm going to create a nice little right triangle, knowing this fact right here, that the tangent of A is 3/2, and the tangent, by the geometric definition of trigonometric ratios, is the opposite over adjacent. Whoopsie. Oh! Sorry. And here's my little triangle right here. It's nice having these problems already worked out. So this right here is my angle A. That's my A. And I know that the tangent is the opposite over adjacent. So what am I going to do? I'm going to find this value K by the Pythagorean Theorem. K squared is going to be 2 squared plus C squared, which is 4 plus 9 is 13. So therefore, K is square root of 13. And if I know K is square root of 13, what's the sine of A? The sine of A is opposite over hypotenuse. Oh, yeah. And the cosine of A is the adjacent over the hypotenuse. The geometric definition of the trig ratios, the exact thing that we started with when we started trigonometry back in, I think it was late January or early February. So now I know the sine of A and cosine of the sine of A and cosine of A, so I could actually put them in here. I know the sine of A is going to be, go down here, sine of A is 3 over square root of 13, and the cosine of A is 2 over square root of 13. I know those values. All I need to do now is figure out what these guys are, cosine of B and sine of B. And how am I going to do that? Well, I'm going to use the other given information here, which was, let me slide down here, ladies and gentlemen, that B is the inverse cosine of 1/4. What does that mean? That means that cosine of B is 1/4. What am I going to do? I'm going to sketch. I got to tell you, this whole idea of right triangles, this is going to be important next year in calculus. Star this. This is going to be very important that you can sketch these right triangles from a given inverse trigonometric expression. Very, very important. Okay, so the cosine of b is 1/4. The cosine is adjacent over hypotenuse, so I'm going to label my right triangle right here. This is adjacent hypotenuse, and I know that k squared plus 1 squared, this is my variable k, is equal to 4. What does that mean? That means that k squared is going to be 15. Oh, yeah. What does that mean? That k is I think I can just clear that off right there. K is the square root of 15. What does that tell me, ladies and gentlemen? Well, if K is the square root of 15, as it is, then the sine of B is square root of 15 over 4, and I know the cosine of B is 1/4, and guess what I know? Now I can plug those back into my original equation, and guess what I have? I think I'm going to go to the next page here because I have that down here. Cosine of B right here is 1/4. Sine of B is square root of 15 over 4. And now all I need to do then, and I will tell you right there, on the written assignment, ladies and gentlemen, if you get right here, stop. You don't have to do this. You don't have to simplify this. And all I did was I multiplied these fractions. 2 times 1/4 is 1/2. And then I took the square roots out of the bottom. You can do this if you feel the need to, but you really don't need to do this. This is where you can stop, and you will get full credit on the written assignment if you stop here, because this is a lot of good stuff right here. And again, on this particular problem, the final answer isn't important. What's important on this problem, I'll go review what's important on this particular problem. What's important is that you know the formula. You know you're going to have to use the sum formula for sine in A and B. And what else is important? You need to know that this is an angle. A is an angle. Inverse cosine of 1/4 is an angle. And then what's really super important for next year is that you could take these values right here and that you can sketch a right triangle to come up with the other trigonometric values. This is tremendously important right here. So just to reiterate. So, okay. So if you need to, at any time, you can pause the video. You can pause the video, take your good notes, and I'm going to tell you right now that there is an example exactly like this on your written assignment this week. So I will talk to you soon. Over and out.